Hello students, today we'll complete part 2 of first unit, that is some basic concept of chemistry, class 11 science. Earlier we have done 7 basic units, 7 fundamental units. Today we'll discuss some of the derived unit. Other than those 7 parameter, any other parameter if you consider, this all are being derived using that 7 basic units. So one of these are mass and weight. Now, what is mass? If you remember, mass was the basic unit and corresponding to it was weight. Mass is defined as the amount of matter present in the substance. It is a constituent of any substance. In contrast, weight is the force that work on the mass. From physics you know that weight W is equal to m into g, where m is the mass into g, that is the acceleration due to gravity. So weight is the force that exerted by the gravity on an object. Next point, the mass of a substance is constant. Okay, do remember, the mass is always constant in the universe, whereas its weight may vary from one place to another due to change in gravity. So if your weight is 60 kg on earth, okay, what will be your weight on the moon? It will be 1/6, that is equal to 10 kg. But if your mass is say 40 kg, on earth it will be 40 kg and in moon also it will be the same, because mass is always constant but weight changes because weight depend on the gravitational force. So to remember it, mass is a constant term. Okay. Next, the mass of a substance can be determined very accurately in laboratory by using analytical balance. The SI unit of mass is kilogram. Okay, mass have the unit kilogram. Next derived unit is your volume. Now, volume has the unit of length cube. See, 3 times length is used, length into breadth into height, and all are being given in the meter. So meter used 3 times, so it is a derived unit. The common unit used for volume is liter, which is not an SI unit. Okay, 1 liter is equal to 1000 ml, or you can say 1000 centimeter cube, that is equal to 1 dm cube. To remember this point, to use it in the while solving the numerals. In laboratory, this point is also important. In laboratory, volume of liquid or of solutions can be measured by gradual cylinders, okay, burette, pipette, etc. So when we will start the practical classes, I'll introduce with you this gadget. But for now, just see here, this is your volumetric flask. Okay, this one is your graduated cylinder. This is called pipette and this is called burette. So these are the apparatus used in the laboratory to measure the volume of liquid or other solutions. Okay, unit of volume is what? It is given as a centimeter cube, dm cube, ml or liter. Next derived unit is your density and temperature. So you know that density of a substance is the amount of mass per unit volume. Okay, mass by volume is your density. So mass unit is what? Standard unit or SI unit of mass is kg, and that of volume you got m cube. So density is equal to your kg per meter cube. Okay, next is temperature. Now there are 3 common scale that we use for measuring the temperature or to express the temperature. Very common is degree Celsius, next is degree Fahrenheit, and The SI unit Kelvin, okay, denoted with capital K. K is the SI unit. Temperature, if you remember, temperature is also a fundamental basic unit or basic quantity whose unit is Kelvin. Now the temperature on two scales are related to each other by this two formula, okay. One is your degree Fahrenheit is equal to 9 by 5 degree centigrade plus 32, and if it is Kelvin scale it is degree centigrade plus 273. You remember the formula, you have to remember the formula. This formula is already known to you, just to remember it, okay. You will note this two formula because sometime for 1 mark you might get the numeral to convert the temperatures, okay. So these are some units. Next, important note over here is the temperature below degree centigrade, okay, below 0 degree centigrade. Below 0 means what? Minus. So that is your negative values. So in degree centigrade you get the negative values, minus 3 degree, minus 2 degree, minus 5 degree, minus 10 degree, like that. In news or newspaper and in news you perhaps heard it or you have seen it. But in Kelvin scale you never get the negative value. So negative value for temperature is possible for degree centigrade scale, but it is not possible for the Kelvin scale. You have to remember it. Now in this chart you can see some temperatures are given. See, human body temperature is 37 degrees centigrade, that is correspond to 98.6 Fahrenheit. Room temperature is how much? Room temperature is 0.25 degrees centigrade, that is correspond to 77 degree Fahrenheit. 0 degree centigrade is 32 degree Fahrenheit, 273 Kelvin. So remember this line, this is very important. 0 degree centigrade is equal to 273 Kelvin and 32 Fahrenheit, okay. And what is the boiling point of water? You know, 100 degree centigrade. So in Kelvin scale add 100 with 273, so it is 373, and in Fahrenheit it come out as 212 degree Fahrenheit. So if you are appearing for entrance and all, this chart must be thorough to you. Next topic, uncertainty in measurement. Here we'll learn about the scientific notation, okay. Now see, since chemistry, the study of in study of chemistry you have to deal with the atoms and molecule, and you know that atoms or molecules are very small in size, even their masses is also very small. So what happened, whenever you deal in chemistry, you calculate in chemistry, you might have to deal with such a number, okay, large number like 602, then see this number so big, right. This is the molecule, this many molecules or atoms may be present. This Avogadro's number is like that, 6.022 into 10 to the power 23. So 10 to the power 23 means that many zeros must be there, that many number of atoms are there, okay. It's a very large molecule. Sometime same way you have to deal with very small values, like if you talk about the mass of hydrogen, then the value come out as minus 10 to the power minus 1.66 10 to the power minus 19 kg or something, gram, like that. So the values become so small, 0.00, so many zero, then you get the value. So in chemistry you have to deal with very extremely large number and extremely small number. So it's a problem while calculating. If you express like this, your problem, your simplification will become too lengthy, too difficult, okay. Lot of confusion you will create. To solve this problem, what is being done, the solution is given as scientific notation, okay. The term scientific notation or the presentation of such a number is given in terms of scientific notation. Now what is that scientific notation? In scientific notation you get this expression, okay, n into 10 to the power n. So this value or this way if you express the number, then your simplification become easier. Now, what is this capital N and small n in this presentation? The capital N have the value, numeral value 1 to 10, okay, with one decimal point. That means if it is 6, you must write like 6.0 something or 6.2, like that. So the value must be between 1 to 10 with one decimal point, and the small n is the power of 10. So this is the way to represent the numbers in chemistry. If you are representing the number in this format, then your number is said to be in the scientific notation. In scientific calculator also, if you just put 3 and you just press equal button over there, then you will see the value will come out or displayed as 3.0 into 10 to the power 0. So that way the formatting is being done, okay, to deal with the numerals easily. Okay, next we'll talk about the term precision or accuracy. Now what is that accuracy or precision? Accuracy is the term that is derived from accurate, and accurate means close to the true value. Suppose you are doing some calculation in the lab, then your value will be termed as accurate, or it will be said that you achieved accuracy when your values are very close to your actual value, true value, okay. In contrast, precision is what? Precision is are the values that are coming again and again, okay, that are being repeated. Several measurements are close to each other. So if you are performing an experiment and your values are coming like similar, okay, then your values or your experiment will be termed as precise. So that is the thing. So see here, suppose you are given a true value of 5.0, okay, that value is fixed. It's a true value, it's a fixed value, real value. You are performing an experiment, okay, first trial you have measured the mass and you got 4.6 gram. Second trial you got 5.2 gram. Third trial you got 4.2 gram. Now these values are not close to your true value. 4.6 far from 5, 5.2 more from 5, like that. So your values are not matching with the true value. So what will be your conclusion? The values are neither accurate nor precise. These values are not common, okay, so it's not precise. There is no closeness among the values, so it's not precise, and moreover the values are far away from the true value, so these are not accurate as well. So that is one thing. So you understood that these values are not accurate and precise. Now another student have done the experiment, repeated the experiment 3 times, and he got first trial 4.2, second trial also 4.2, third trial also 4.2. So see here also the values are far away from 5, so the value is not accurate, but the values are same, similar, very close to each other. So these values are not accurate, but this value is a precise value. Hope you understood that accuracy and precision. So accuracy means what? It is the value that is close to actual or true value, and precise means the values several time if you repeat, the values will be close to each other. It's not necessary that it will be close to true value, but repeated values must have some similarities. Now see here another example. This is the student, they are performing yes, they are performing the experiment. So Ramesh, first time he did some measurement and got 2.80. Second time he measured as 3 and he got the mean 2.9. okay, so these values are not same. 2.83, 2.9, if you consider not same, so it is not precise. Okay, Achha, one more thing to tell you, here the real value is 3. okay, now one value is close but two values are not close to the real value, so it is not accurate. Next, Suresh have done the experiment. See, he got 2.91, 2.90, 2.905, 2.9, 2.9, 2.9 common. Okay, so the value is precise, but again it is not close to real value 3, so it is not accurate. Then Rohit performed and he got 3.01, 2.99 and 3. See, 2 times he got 3. Okay, close to real value. So yes, his values is accurate, and moreover 3.01, 2.9 and 0.01 difference. Here also 3.01 and 3.01 difference. So difference is very less, and hence we can say that yes, his calculation is precise. So Rohit got precise and accurate values. Then for Rakesh, 2.90, 3.10 and 3. Okay, the values are close to 3. So this is accurate, but no similarities among the values, so the values are not precise. So that is your precision and accuracy measurement. So by seeing a data, you can tell whether the values are precise or accurate. Okay, and precision and accuracy is very important to remember. Accuracy is close to real value, and precision is closeness to the values you obtain, right? So that's the thing. That's all for today. Thank you.